A little bit of an overview of kind of world classification. I was secretary on the International Vegetation Classification Working Group for the last 3 years, and also I'm one of the ones running the biome classification workshop, which was just discussed in Bozeman, so I'll see you there. Basically a little bit of a background, although Sarah's just given a little bit of this, so I'll rush through some of it. Of course, we all know why we want to classify vegetation. It's like defining species. We need something to work with. So we need to classify, we need to have units that we can do things with and think about, basically. As you've heard, we've been classifying for 200 years, and of course we've got it all worked out now. I wish that was the case. Lots of schools of thought, but things have been changing, as you heard about. Originally, everything was based on opinion. Usually some person came up with a classification and imposed it on everybody else. And that's certainly been the case in Australia. In all the different states, we seem to have somebody who's taken on that task to describe all the vegetation in their state. But now we use lots of plots, and we try to analyse them, and we try to have them in large data sets, although I hear that's a problem here. And of course we try to now collaborate across borders, except that message hasn't gotten to Australia yet. But hopefully one day different states will talk to each other about how to classify their vegetation. Really there's a couple of trains of thought which we've heard about. Phytosociology, which is basically just talking about species and species on their own. Now this is a real science in Europe. This is where you actually publish, like you would publish a species, you'd publish a nomenclature. So you'd say, okay, we've got this Kaluna and this other species, and you'd actually use that as a binomial. So the communities have a binomial and you publish them. But it's totally down to what species are growing with what species. No other things are considered. And then you have physiognomy, which a lot of Eastern Australia uses, which is just structure. So the species is no longer important. It's down to the height and how many layers. In terms of rainforest vegetation in Eastern Australia, it's based on leaf size. And never the twain shall meet. Although people try to bring those two schools together, they are actually different ways of looking at the universe. And so there's a bit of an overlap, but quite often they don't overlap very well at all. So why use plots? Well, the bottom line is probably the most important there. We are not as good as we think we are, and experts can get in the way. There's been a lot of analysis overseas, which has shown very clearly that people are just inconsistent. And that usually when we come up with a classification system, particularly when it's been brought together by individuals, there's very little detail about how the hell they did it. You can't go back and repeat the same process because there's no real rules about why certain things were defined and why others weren't. They're very idiosyncratic. And there's been a great study done by Etta Adicott, who she's just about trying to get her stuff published, where in Queensland they have a very clear way of defining communities that has been done by experts. And the same process she used in defining them by analysis, and some great things came out of that was that basically there's a bit of an overlap between analysis results and expert opinion results if there is a real sharp disjunction between communities. So let's say a wetland and a neighbouring woodland beside it. You would call the wetland different from the neighbouring woodland, so would the analysis. So there's a little bit of an overlap there. But in general, if it's not a really sharp distinction, we're terrible at it. Really bad. So analyses are actually quite important to do. They bring up a lot of systems that we might not have even thought existed. Some of these plot numbers are a little bit different. We heard a lot more plot numbers from New Zealand. That's because basically I'm working on a different group. This is the number of plots that these different countries have used to define their classifications when they have gone down the path of using analysis. And so UK thinks they're finished, completely and utterly finished with their classification system. They don't need any more plots, they don't need to think about it again. But I guess it is a very small place and they've taken everything out. China's really good, 1 million. I would like to see that analysis, and of course they say, Tichi says you can do 3 million. Okay, I'm not quite sure I want to work through that dendrogram and all that kind of work, but anyway. So there's a lot of numbers there, and but surprisingly not as big as you would think for a lot of things. Czech Republic really surprised me. It's a tiny place. They must be very close together, those plots. In Australia, these are the plots that are publicly available, basically, for people to use, and we've mapped them all out in a recent publication. And as you can see, they tend to occur all in one place. It's like, you know, everything's fallen down into one part of the country. And WA... and in terms of bioregions, we did analysis of wet bioregions and how well they're done. It really is appalling. Australia is not doing very well with plot-based studies. And I guess I put this up, it's a bit of an ego trip, but these are my 27,000 plots. And I've been databasing since day one. I mean, since 1992 I started putting in a relational database, having all my plots that I've ever done. So if I can do this as a single person, what's holding the governments back? Or you know, I'm a little bit bemused. What do we need? We need high quality, updatable, open access, secure, database plot data collected in a standard way, nomenclatorial integrity, and that's what is happening all over the world. We all should be following this same example. It's absolutely necessary when we want to do good quality classifications, or we want to know what's really going on in the world. And I truly believe that classification should be as much as possible unsupervised, which means they should be done without us manipulating the data too much. As much analysis as possible, less people thinking they need other answers than what they're getting. There's some interesting examples I've worked with recently where people and experts get in the way. North Coast of New South Wales are doing a great big analysis. I like to think of classification of vegetation the same as I do with plants. So I started off in plant systematics, so I think very much in that way. I think it should be hierarchical, and you know, there's complexes. Vegetation, there's some things that are really distinct, others that are just complex, and you may not truly work them out. And there was a great example where we had one great big community that was quite widespread on the North Coast, and the discussion there was, we think this is too big. It's covering too much country. The analysis actually says there's no difference in this vegetation. It all looks very much the same species are in there, but it's just too big. So the decision was to break it up into about 6 or 7 different communities, which of course, because all the species are the same, you'll never be able to separate anyway on the ground or with analysis. But it was just too big. Another one was where we did some work out in Western New South Wales. We did a great big classification of all grasslands out there, and the government wanted a Bothra community. There's none in the data. Yeah, but we want a Bothra community. And so they manipulated the data afterwards to make a Bothra community. Again, because it doesn't actually, you can't pull it out of analysis and things like that, you'd never be able to recognise it. And one of the reasons they wanted it is they wanted to make a threatened community. Of course, you know, you guys are well aware of this. Anybody who works in vegetation is, there are some complications about vegetation, and I think one of the things is that we need a lot of permanent plots. It's not just about having lots of plots, I think we need to have a lot of permanent plots out there as well to understand our systems. One of my PhD students did some work very much the same as what Kelly did, looking at vegetation But this was vegetation that isn't supposed to change. It's temperate vegetation in Eastern Australia. It's supposed to stay the same most of the time. Of course, there'll be a spring peak where you'll get more species, but he looked at it every 2 months for 3 years. And even in this fairly supposedly stable system, at any one survey period, he could only find 50% of the species that would appear in the 3-year period. And that basically, to even get a majority of the species, you needed at least 2 survey periods. And of course, as we've been hearing over here, you have that situation quite clearly. And then you have things like ephemeral wetlands, which can turn from this to this to this to this to this, and that can happen within a year, or it might take 10 years to happen. Either way, there's a whole stack of communities within the same place. I've just been working on permanent plots out in Western New South Wales, and one of these areas here is very unpredictable in climate. It sits right on the crossover between summer dominant and winter dominant rainfall, and so the rainfall can happen at any time, really. Plus it's, it might rain well once every 10 years. And the changes there were just phenomenal. I mean, this is the rainfall deficit over 4 years, and that's the biomass decline. And basically, this was a bush heritage property, so what they wanted to know was, are we doing the right things? When they took over, it was like this. They removed all the cattle, they removed all the goats, and they removed everything. And we've actually got one more set of data after that. And the average, the same plots, we went from 20 taxa on average to 16 to 5. And the communities, overall, but there were very different in some communities and others, but basically, we just swapped from one kind of system to another. Some of those were quite massive structural changes, such as some of the wetlands went from grassy systems to myroporum dominated. But next time it rains and floods, the myroporum will all die out and the grasses will come back. I guess the point here is that we also have to remember that there's a dynamism in vegetation classification. It doesn't mean that we can't do vegetation classification, we just have to remember that when we go to map it, there might be more than one system within that map unit. And we've got things like fire, of course. I started off, my PhD was on granite outcrops. And so, what we've got here is a whole endemic community on a granite outcrop. Most of them are fire avoiders. We put a fire through and we get a completely different permanent community for a while. I say permanent in that it will be decades before the endemic rare species come back in. So again, it's just part of that dynamic change that we have to think about. One of the things that we have a problem with is that there's a lack of data, and of course you guys would know all about lack of data. But that stops us from actually trying to work out a classification. One of the things that I've been trying to look at the moment is, can we do parts of a classification without waiting until we have 200,000 sites? And of course, one of my colleagues, and we've just done a recent rebuttal, we think you guys need at least 200,000 plots publicly available in a good relational database that's updated nomenclature and all that kind of other stuff. But what do you do if you don't get that? Can we still start doing some classifications? And I think we can. If we partition it and we start looking at kind of entities within the system that might be able to be worked with. And one of the things we did was look at ephemeral wetlands in Western New South Wales, and we had a reasonably okay data set of around 700 plots, and we tried an eco-regionalisation first, which is just looking at where those wetlands were first and looking at all the, I guess, the environmental layers that described those locations, those wetlands. So we took 200 GIS wetland mapping layers, and every wetland that we had, plus we also did a bit more mapping ourselves, we characterised those spots based on their environmental characteristics. Their soils, their climate, rainfall, whatever, slope, all sorts of things. And we tried to define how many distinct units, climatic, environmental units there were there, based on the wetland locations, the analysis came out there were at least 3 distinct types of ecoregions for these wetlands. So what we've done is we've done an analysis for a single vegetation community type. And within that, we then did analyses of the actual floristics. So what we're trying to do here is actually come up with a classification not at an association level, because that we want a lot more sites than that. We wanted to come up with a much higher level one. So in terms, maybe thinking of order, if you were to describe in terms of species classification, order or family, somewhere up in that level we were trying to look at. And we did some Kanoko analysis of life forms as well to try and help us inform kind of how life forms were changing in these different systems. And basically we were able to describe a whole set of, in terms of eco-vegetation, which is a classification technique that a lot of North America uses. We came up with 2 hierarchical levels, the macro group and the group level, and we're able to define positive diagnostic species for each wetland type. So in other words, if you have these, you're probably in it. If you have these, the negative type, then you're not in it. So positive and negative way of defining whether you're in the community. And then common taxa. So the positive diagnostic and negative diagnostic taxa aren't necessarily the most common, but these are the ones that you most commonly would find in that system, and then notes to define each. So that was using plot data. Another one we just recently attempted was to look at, can we do the same thing if we don't have plot data and we just have herbarium records? So in this one we looked at riparian vegetation across New South Wales, and we looked at 1 to 1 degree grid cells, and we tried to have at least, I'll go back a step. We picked species that experts thought were very restricted to the riparian environment and only looked at those species alone. Now, if more than 3 of those occurred in a grid cell, we considered it a cell we could work with. And again, we did an eco-regionalisation process on the grid cells that had riparian restricted species in them. And basically that led up to 1,731 grid cells, which followed very nicely along all the known riparian corridors. So hopefully we got that right. We used climatic and landscape variables, and basically used a similar process to what I did in the past one. But like I said, this is just using herbarium data, and we're able to come up with macro groups with dominant species that define riparian areas. Now, the hallmarks of a good classification, this is from D. Caceres, and basically this is what everybody should be striving for, and that is comprehensiveness, consistency, so that there's a method that you're always using that other people can follow. They can follow the recipe. Robustness, if you throw in a few extra plots, it's not going to change the answer, or the major answers anyway. Simplicity, that the definitions are easy, so that if you've got a plot, you can put it into a system without too much trouble. The distinctiveness, that goes back to a bit of the simplicity. If they're very distinct, they're easy to deal with. Identifiability of units, identification of context. So one of the things that's important is that when we do a classification of vegetation, it's purpose-built, really. It's not going to answer everybody's questions, but when you build a classification, there's always a reason behind it, which, unlike, this is where I get away from it being the same as describing species. Species, you're hopefully getting to a single entity that everybody will agree is a species. When we come to community, it's really based on where you start, what your aims are, where you're heading for. You can have, it's having a version of the world. And every time you classify, you can come up with a different version of the world. compatibility, that there's relationships with other vegetation types and systems. So if you do come up with your own version of the world, you have to have a way that it can link to other people's versions of the world, other people's classification systems. And of course, if we have a very clear way that we've done the analysis, and very clear way of saying, okay, this is how we're going to treat the results, then you can work your way backwards and link yourself to other systems in a much easier way. Of course, one thing that many of us will know, but I'll still bring it up because I have a terrible trouble with government departments all the time with this, is that like photosociology and structural versions of classification, mapping is not the same as vegetation analysis. When we come up with communities with vegetation analysis, they're one way of viewing the world. And quite often, they overlap with how we view the world in a map. And yeah, 30% of the time your vegetation community will be really mappable and easily mappable. But when we map vegetation types, we can't map everything we conceptually come up with in a classification. And vice versa, we can map some things because mapping often comes down to structural differences which don't show up in a classification. They're not the same thing. That's just a little bit of my bugbear. I think that's about it. Did I run short this time?
Questions? So again, you're looking at presence and absence.
No. Presence and absence with the variant data, because that's all you've got. But with the plot data, no, we were using, we had most of those they were done with Braunville K, cover abundance data. But again, that's part of the recipe. So your recipe is described, people can know exactly what you did and follow it. So it doesn't really matter whether you use presence, absence or not. What matters is that everybody knows what you did.
So it is possible for WA to get a decent map, and actually it'd be scalar then. Because one of the issues that I've faced is the scalar thing and maps not matching up, and then when you do try and blend them, you actually needed a botanist to come back and actually go and revisit the whole work. So in theory, you can potentially remove that issue.
In theory, I think you can. That's what we were trying to work out, or trying to provide some examples of. The examples that I provided of those two isn't necessarily what I think everybody should do, but what I was trying to illustrate was that there are ways of thinking around this problem. That yes, government isn't going to fund you to do 200,000 sites. Can you start to get parts of the classification done? Okay, this type of vegetation, we might have enough sites to actually start doing classification. We don't have to wait till we have all the vegetation in a database. And same with some areas, because I think we need names, we need units to work with. And if we know where the data is usable, and it could be only at a high level, it might only be a division, macro group, it might not be anywhere near an association, but that level is still a useful tool as long as you know the limits of where that level is. And I think also having a hierarchical system allows more flexibility with working within vegetation classification. So if you're doing a statewide kind of look at some issues, you might only want to be looking at the larger or the higher levels of classification. If you start working at association level, it just might be too much noise. But again, if you're working at a local level, you don't want to be working at those macro group levels, you want to be working at association.
John, another very interesting presentation. I guess my question was, So with the New South Wales situation, I guess there's two parts to the question. Firstly, are most of the plot-based data then that you have access to for New South Wales actually include abundance and cover data? And then the second part of the question is, how much of a constraint is it, do you think,